So the topic for today's class is Introduction to Hive. Hive is a sub-technology just like HBase, and it also depends upon Hadoop. So let's start the class with the agenda. The agenda for this class is limitation of MapReduce, Hive Overview, data versus metadata, pros of Hive, cons of Hive, Hive uses at Facebook. So this is a small agenda for introduction to Hive, and let's start exploring with the first one, that is limitation of MapReduce. So MapReduce code is not reusable. In our previous Hadoop developer classes, we have noticed that whenever we are writing a MapReduce program that is specific to the requirement, we had written a MapReduce program for word count. So that program can be used only for counting the words. It can't be used for anything else. Second thing is, if you are writing any word count for MapReduce job for searching or sorting, you have to write it from very beginning. That means for every new requirement, you have to write a new MapReduce program. And while writing the program, you must have noticed that the programming part of Hadoop is little complex. Multiple stage of MapReduce functions. We have to write the mapper program, reducer program, data type of input key value pair of mapper, data type of output key value pair of mapper. Similarly, data type of input and output key value pair of reducer, and many more things. And in case we have to write multiple stages, that means the output of first MapReduce job will be used as input by the second MapReduce job. That means there is a dependency between different MapReduce job. So if we have to write a MapReduce programs with some interdependency, that would be even more difficult, and it's error prone. If you will make any small mistake, output key value pair of mapper is going as input key value pair of reducer. If there is any mismatch in the data type, the program will not be running. So we have to be very careful while writing the MapReduce programs. So these are the few limitations of MapReduce programming. So let's move to the next slide. The next is Hive Overview. So Hive is a sub-technology under Apache, a data warehouse for Hadoop. It makes structured data looks like a table. What do you mean by looks like a table? Are they not the real table? No. If I compare with RDBMS, in RDBMS data is looking like a table and data is actually stored in a table. But if I talk about Hive, data is looking like a table, that's true, but it's not actually stored in a table. Instead, it's stored in a text file, and the text file data is looking like a table. In upcoming slides, when we will be installing Hive and will be doing the things practically, it will be more clear to you. SQL based query can be used on these tables. If I compare with HBase, which had very different query syntax. If I talk about Hive, it is quite similar to RDBMS. So SQL based queries can be used on Hive tables. So select start from table, order by, group by, where clause, and joining of multiple tables. All these things you can do very easily in Hive. So queries are automatically converted into MapReduce jobs which are executed on Hadoop cluster. This is the core concept of Hive. As a user, you can concentrate on writing the SQL query. But behind the scene, SQL query will be converted into MapReduce job and that MapReduce job will be executed on Hadoop cluster. So if I talk about the dependency, HBase was dependent upon Hadoop only for storage part, only for storing the tables data. For processing part, HBase had its own capability. But if I talk about Hive, for storage and for processing, it's completely dependent upon Hadoop. Because every Hive table is backed up by a text file which is stored in HDFS, and every Hive query is converted into a MapReduce job, and those MapReduce jobs are ultimately executed on Hadoop cluster. Depending upon the complexity of your query, it may be converted into single or multiple MapReduce job. If you are using a join, if you are using a subquery, in that case your query will be converted into multiple MapReduce job. So this is very brief about Hive. So the next slide we have is data versus metadata. If I talk about RDBMS, Oracle, Microsoft SQL Server, Teradata, in those softwares, data and metadata both are stored at the same place. Data means your actual tables data, and metadata means your table definition, table name, column name, their data type, which one is primary key, and all other stuff. On the other hand, if I talk about Hive, Hive depends upon HDFS for storage. Hive tables data is stored on HDFS. Big tables are suppleted and stored on multiple machines distributively. The same was happening in HBase also. The big tables were suppleted and stored distributively on multiple machines. That was about data. What about metadata? Table name, table definition, and that metadata is stored in Derby by default. Derby is a small database. You may not be aware about that, and you may not have heard that name. And that comes along with your Hive. No need to install Derby separately. When you install Hive, Derby will be automatically get installed. But Derby has a limitation. Derby does not allow more than one concurrent connections. That means at any point of time, you have one connection to the Hive. One user is already connected to Hive. At the same time, another user wants to connect to the Hive. That means at the same time, we want multiple concurrent connections. So that is not possible with Derby. And for learning purpose, that's not required. Because for learning purpose, an individual person can create a connection to Hive. He or she can execute the queries, and that's all. But in case of a team, when you are having multiple team members in the team, and all the team members are trying to connect to Hive at the same time, that means ultimately we need multiple concurrent connections. In that case, if you can use any JDBC compliant RDBMS, Oracle, Microsoft SQL Server, or MySQL or Teradata, we can use any JDBC which is JDBC compliant, and that can be used which provide more than one concurrent connection. But RDBMS will be used only for holding your metadata, only for providing you the multiple concurrent connection. Otherwise, as far as your data is concerned, that will be still suppleted and stored distributively on multiple machines on Hadoop cluster. So this is where exactly the data and metadata of Hive tables are stored. So next slide is pros of Hive. The benefits of using Hive. depends upon Hadoop for storage and processing. That means the feature which are already there available in Hadoop, like splitting your big file into smaller parts, storing those parts distributively on multiple machines, keeping duplicate copies, and while processing, if something is down, some system is down, rescheduling of that job on some alternate system. All these features will be automatically available for Hive. The more interesting part is no need to write MapReduce program. The people who are coming from non-Java background and earlier they had to struggle with MapReduce programming, I think those people will be quite happy to know that in Hive they don't need to struggle with MapReduce programming. They can write the SQL queries which can be easily converted into MapReduce job. That means Hive will be writing a MapReduce program for you, and ultimately you can uh, execute that job on Hadoop cluster. So it's an easy way to process large scale data. Support SQL based queries. No need to write any, no need to learn any new syntax. The existing syntax, if you are coming from SQL background, you will be aware about the basic query syntax of SQL. All the features like indexes, joins, group by, these features were not supported by HBase because that was a NoSQL. That was quite far from SQL. On the other hand, if I talk about Hive, it's quite closer to RDBMS and it's 90% similar to RDBMS. So all the SQL feature, indexes, joining, group by, order by, all these things are very easily supported by Hive. It provides more user-defined interfaces to extend. Apart from the features which are already there, if you feel that there should be more features which are actually not available in Hive, in that case Hive is giving you the flexibility that you can extend the interfaces. You can write your own feature and you can add those features to Hive. In the upcoming classes, when we will be doing a POC, proof of concept, we'll be doing a mini project. In those classes, we'll be exploring it in more detail, how to add a new feature to the Hive. And the last but not the least is efficient execution plans for performance. As a user, when we are writing a MapReduce program, that may be or may not be the best possible solution. But Hive is properly tested and verified. When Hive is writing a MapReduce program for you, it will consider all the scenarios, it will consider all the performance improvement techniques, and ultimately the MapReduce program which Hive will write for you, that would be the best possible solution for your requirement. So these are the benefits of using Hive. Let's move to the next slide. The next is cons of Hive. What are the limitations? What are the disadvantages of Hive? The first is you cannot edit data in Hive, and you know the reason. Behind every Hive table there is a text file stored in HDFS, and when you want to edit something, edit data in Hive table, that means ultimately you want to edit the data in text file, and that is not possible. You cannot delete a particular row from table. Even deleting a particular row from table is ultimately deleting a particular row from a text file. That is again editing. So you can't even do that. Default database Derby, which we talked about in the previous slide, does not allow more than one concurrent connection. So that's a limitation, but we have a solution for that. We can use it for we can use any JDBC compliant RDBMS which can provide more than one concurrent connections. Not suitable for real-time application or transactional purpose, because when you are doing real-time application or transaction, within fraction of seconds we have to respond. When you are swiping your credit card in a shopping mall, your bank has to respond immediately with a status whether your transaction is approved or it is rejected. But as far as your Hive queries are concerned, those will be converted into MapReduce job. That MapReduce job will be submitted on Hadoop cluster. Then mapper will be running, reducer will be running, and final output will be generated. So it will take some time. You cannot expect that Hive will quickly give you the result within a fraction of seconds. Hive can't do that. It's used for offline batch analytics. When you have large amount of data and there is no requirement of getting the output in real time, you can take your time and you can analyze the large amount of data and come up with some useful stats. In those scenarios, Hive can be used. The next is you cannot access Hive tables if Hadoop is down. That's true, just like your HBase. If you're dependent upon Hadoop for the data or for the processing and somehow Hadoop cluster is down due to some failure or some maintenance activity or commissioning or anything else, in those scenarios you will be not able to access your Hive tables data. Once your Hadoop is recovered, once your Hadoop is up and running, you are back and you can access your Hive tables easily. The last is more operators required. Primary key concept is not there in Hive table. Exist in RDBMS we can use exist, that is particular column, and we can provide some values. Exist operator is not there in Hive. And views in RDBMS we have a concept of views as well, which is not yet supported in Hive. So these are the you can say limitation of Hive. Let's move to the next slide. Hive usage at Facebook. Facebook is extensively using Hive for its business intelligence, for making its advertisement more effective. So we have few stats for Facebook. You can have a look. 40 terabytes of compressed data is added on daily basis. 15 petabytes of compressed data is processed daily. We are doing some analytics. People from different geography, different gender, different age group, with different educational and professional background are clicking on different type of advertisements. Every click you do on any advertisement on Facebook is captured by Facebook team, which can be later on analyzed for its business intelligence. 10,000 plus Hive jobs are executed daily. Hive simplifies Hadoop. The people who felt difficult to use Hadoop because they had to write the MapReduce program, Hive has simplified that. Because now you don't need to write the MapReduce program. You can access your Hadoop through Hive. So approximately 500 people per month are running jobs on Hadoop and Hive. Analysts use Hadoop through Hive. The people who are not from Java background are quite happy that they can now access the Hadoop through Hive by writing the simple SQL queries. 95% of jobs are Hive jobs. Most of the scenario you can achieve the required output by writing a SQL query, but in some special scenarios you may need to write a MapReduce job. You may have to write the MapReduce program by yourself. So we cannot move away from MapReduce programming. Whether you write the MapReduce program or Hive is converting your SQL query into MapReduce program, ultimately on Hadoop cluster the MapReduce job will be running. So this is about Hive usage at Facebook, and with this slide we are done with introduction to Hive.